Okay, good morning, students. This is Mr. Galambos, and today we are doing rock transformations, learning about rock formations and their samples. So, my warm up for you today is for you to type in how do you think rocks form? Thank you for completing the warm up. That is what we are going to learn today. We're going to learn all about how you think rocks form. In this unit, we will investigate how rocks form in the first place, and then after that, how do they change or transform? Our unit question is, how do rocks form and change? Pretty easy. What on earth is a rock? So, in order for us to look at how rock formations change and form, I brought a sample from the Rocky Mountains, and Mr. Wolverton brought a sample from the Great Plains. Let's look at a map showing these locations. The Rocky Mountains span across New Mexico, Colorado, Wyoming, and Montana. The Great Plains span across North Dakota, South Dakota, Nebraska, Kansas, Oklahoma, and Texas. I was born right here in the heart of Colorado, and I will show you a video of the Rocky Mountains right now. The chapter 1 question is, how did the rock of the Great Plains and the Rocky Mountains form? Did they form in similar ways?
We went, I didn't see the northern lights. It doesn't have to be Sweden, I just want to see the northern lights.
Good. Or in different ways? So, in order to think like a geologist, first we look at the surroundings around us. What I want you to do is to observe, what do the Rocky Mountains look like, and observe, what do the Great Plains look like. Write down your observations below. In order to understand more about the way things form, we have to do a little vocabulary. Matter is anything that has mass and take up space. Solids, liquids, and gases are all types of matter. A sample is a small part that is meant to show what the whole is like. This man is serving samples of cheese, and they're taking samples of cheese in order to see if they would like the whole cheese. A rock formation is a region of rock that formed together as a single rock type. So each one of these bands, these striations or stripes in the rock, are all types of rock formations. This is a rock formation. This is one. This dark red color is another one. When I look at all these rock formations, I can take a sample of rock from each of them. So from this light band in the middle, which is more sandstone, I can take a sample from that of one small sandstone rock. This will look differently from sandstone or another type of rock taken there. So we want to figure out, did the rocks from the Great Plains and the Rocky Mountains form in similar ways or in different ways? This is a sample from the Rocky Mountains. Write down, what do you observe about it? What do you see about it? Okay, this is a rock sample from the Great Plains. What do you observe about it? What do you notice about it? What kind of colors is it? What does it look like? What might it feel like? And now I want you to predict, do you think these rocks formed in similar ways or in different ways based on how they look? Like me, I would predict, personally, just by looking at them, that these rocks were formed in very different ways. Minerals are pure inorganic substances that all rocks are made out of. These are crystals and certain structures that are found in all rocks. All rocks are made up of a combination of all of these minerals. What if I told you that the minerals in these two rocks are actually really similar? Even though they look completely different, what if I told you these minerals are actually very similar? Does that surprise you? We have two claims about these rocks on how they might have been made, even with similar minerals. Claim one is they formed as one rock formation and then something separated them. And claim two is one rock formation formed before the other, then the minerals from the older rock became part of the younger rock. Make your prediction. This does not have to be a right or a wrong answer, but what is your prediction on what happened with the rock? The key concept here, these rocks, these two rocks, look very different, but they have similar minerals. Rocks can form in many different ways. Even though they have similar mineral compositions, this causes them to be different types of rocks. So we're going to continue learning about how do rocks form. I'm now going to model how different rocks form using a simulation. A simulation is a model or a representation of what happens in real life. Models are important for helping us study this topic because rock formations can form over millions of years. It can be nearly impossible to observe this in the real world because it takes so much time and it spans over so much area. In order to understand the simulation, we have to understand what a map view is and what a cross section is. A map view is what the top of something looks like. A cross section is what the inside of something looks like. A sediment is a small broken down pieces of rock. So now I'm going to open the simulation and we're going to go over it. So when I open the Amplify, I'm going to go to Rockford Transformations 1.2, 1.3, sorry. And we are going to go over this warm-up. This is a map view of a landscape. It's asking you to label it with 3 different labels: a mountain, an island, and an ocean. I want you to predict where each of these will go in your own video. Great prediction. The island is going to go there, the mountain is going to go there, and the ocean is going to go there. This is a top-down view, what something from the top looks like. When I scroll down, this shows the cross-section of the landscape. I want you to predict where the labels mountain, island, ocean, and mantle will go in your video now. Great. The island is here. The ocean is here. The mountain is here. And the mantle is here. Very good. If you want to do this on your own time and hit hand in, that would be great. When I go to the simulation, it shows a very similar view of what we were looking at. We can see one oceanic plate, tectonic plate, crashing into one continental plate. When two plates crash into each other, what type of plate boundary is that called? Very good. This is a convergent plate boundary. I can add sediments to the simulation. Sediments are little tiny pieces of broken down rocks that crash into each other. They're like pebbles or gravel. I can also weather down this rock. That means rain, water, wind are crashing into this rock and breaking the rock into itty bitty pieces of rock or sand. These sediments will align in the simulation, and after millions of years, they will compact down on top of each other to create a new rock. These sediments will crash down into each other and create a new rock. I can hit Analyze Rocks in the top corner, and I can see that these sediments are loose, but when they crash into each other, they can create sedimentary rocks like sandstone or shale. Let's go back to the presentation. How long do you think it takes for each sedimentary layer in this rock formation to form? That's a great prediction. Sometimes each layer can take thousands or even millions of years to form because it takes a lot of time for the sediments to press and compact together. Our vocabulary word is sedimentary rock, the type of rock formed when sediment is pressed and glued together. Sedimentary rocks are formed when sediment is pressed and glued together. We can see we have a lot of loose sediment, but over thousands of years, these sediments are compacted together before being cemented together or glued together to create really strong rock. Compaction is the process of sediment being buried and pressed together. Cementation is the process of sediment being glued together. Compaction and cementation are both processes that create sedimentary rock. The key concept: when sediment is compacted and cemented together, it forms sedimentary rock. Let's look at how igneous rocks are formed. So now I'll go back to my simulation. In the simulation, we can see we have mantle. The mantle in orange is soft, solid rock. When the mantle is melted to super, super hot temperatures, it becomes magma. When the magma comes up to the surface, it becomes lava at the surface, and when the lava cools down, it creates a new type of rock. We can watch that happen again. The magma comes to the surface, it cools down at the top, the lava cools down at the top, forming a new rock. We can analyze these rocks. This is rhyolite. It is an igneous rock. It was formed when the magma came up to the surface and cooled down. We can also watch a video of this happening. This is lava flowing out of the top, and it's super, super hot rock. As it cools down and creates the black rock around it, though that is igneous rock. So let's go back to our slideshow. Magma, hot liquid rock below the surface of the earth. Basalt is one kind of rock that can form when on Earth's surface when magma cools. In this image, you can see some lava has cooled enough for rock to form, and it's cool and solid enough to walk on. But this orange glowing rock is still super hot. Igneous rock is the type of rock formed when magma cools and becomes solid. When magma cools, it hardens to form igneous rock. So now we want to go back to our main question. How were the Rocky Mountains and the Great Plains formed? Looking at these images, how do you think, and knowing what we just learned about magma and igneous rocks and sediments and sedimentary rocks, what do you predict the Rocky Mountains are made out of? And what do you predict the Great Plains are made out of? One thing we observe about the Great Plains is that there are many small rocky hills made out of crumbly rock. The hills are covered in brown and green grass. One thing we observe about the Rocky Mountains are they have jagged tops. The chunks of the rock vary in size. They appear to be light and dark gray. Once again, let's predict. What do you think the Great Plains are made out of and what the Rocky Mountains are made out of? So now I want to show you a model of how the Rocky Mountains were formed and how the Great Plains were formed. This model is supposed to represent what has happened over millions of years, but it is not a perfect model and has many limitations. Here we have an oceanic plate underneath the Pacific Ocean crashing into the continental plate that North America sits on top of. When these two plates crashed together, creating a convergent plate boundary, these Sierra Nevada mountains were pushed up. You can see the oceanic plate colliding with the Sierra Nevada mountains and the tectonic plate going back down into the magma. But then something very unique happened. The tectonic plate curved back around and it continued growing back up toward the surface of the mantle. When it crashed all the way in Colorado, it started to create the Rocky Mountains. It pushed up mantle to create new rocks. As the continental plate grew longer, the mountains got larger. Because these rocks were pushed up from magma, these rocks are igneous rocks. After millions of years, the continental plate went back down into the mantle to melt to become magma. Weathering happened on the mountains. Rain, wind, rivers were created, which slowly, over millions of years, broke down the Rocky Mountains and created layers of sediments. It created another layer of sediment, and then it created another layer of sediment. This is how the Great Plains were formed. The Great Plains sediments were created from weathering down the Rocky Mountains. So, when we go back to these two rocks, they look very different, but they have very similar mineral compositions. From what we just learned in the model before, why do you think the mineral compositions of the sedimentary rocks are similar to the igneous rock? That's great. The sedimentary rocks have similar mineral compositions because they were created by eroding and weathering down the igneous rocks of the Rocky Mountains. So even though these rocks look very different, that is why they are very similar. So we have two claims. The rocks formed as one rock formation, then something separated them. Or one rock formed before the other, then the minerals from the older rock became part of the younger rock. Re-answer which claim is more true after what you just learned. Thank you very much. That is how the Rocky Mountains and Great Plains were formed. And what are sedimentary rocks? What are igneous rocks? And why these two rocks may be similar. Have a good day.